So, imagine living in a world where sources of electricity were so abundant that it was practically free. In such a world, we would no longer need to be dependent on things like fossil fuels or natural gas or other precious natural resources for energy. Maybe no more forests to cut down, no more gas to burn, no more pollution. And what if someone told you that they had built a machine that could accomplish just that? Not only being able to power itself, but also being able to power other instruments. I would hope that all of you would immediately be skeptical about such a claim, and also curious as to the truth of that claim. So that's the nature of the subject that I wish to investigate in my presentation today. Whether perpetual motion and free energy is in fact science or pseudoscience. So let's begin. So I want to start off with a video. This video clip is from YouTube. It's on there's this company, Magna Coaster. Vortec, that aired in 2008. Not sure if some of you watch like Dragon's Den. Okay, so this is one of the videos that was this is one of the proposals that they had for the dragons. So
your speaker's really loud. You'll probably catch it on the microphone.
Okay.
Next in the den, Richard Willis with his innovative way of amping up electrical power.
What I've done is I have a unit that takes in 18 watts of power and produces 50 kilowatts of power. After I got electrocuted the second time, I called the University of Waterloo. We actually had them do some testing, and the first time out into Waterloo, I was 2,600% above unity. Over unity means you put less in and get more out.
So, excuse me, Richard, for being a skeptic. It's my nature. You're telling me that a multi-billion-dollar industry that's trying to solve solar power hasn't been able to do this, but you have in your garage?
Basically, yes.
So you got the money, right?
Well, so that segment ends with Richard Willis making a deal with one of the dragons for $500,000 under the condition that the technology actually works. So there's some interesting things to say about Magna Coaster, just interesting sort of facts. No deals have been made as of 2011. There's accusations that Magna Coaster has accepted money for their products and not shipped them out. And there's no confirmation from Waterloo that those tests that he claimed were made ever took place. So that's not to say that his claims are wrong, just somewhat troubling. So in order to begin the implausibility, to understand the implausibility of these claims, we have to sort of begin to look at what physics has to say about them. So to begin, we want to get to the point where we can talk about what energy is, so let's start off with what is not energy. Maybe some of you guys have seen this video with Dr. Werner, the homeopath, on YouTube. It's a really great video, really interesting, and she has a lot of interesting things to say about physics. All of them are wrong. Yeah, unfortunately, energy is not equal to, m with the m almost crossed out and the c squared in strings. That's not what energy is. She did get a few things in the video right, namely the fact that we have eyes and ears, and so she got some things right. The scientific, the way to say how badly she failed is really just, it's an epic fail. So to begin to understand what energy actually is, we have to first talk about just physical systems. So I'm going to define a physical system as this arrangement in it's a closed system in space that will contain a lot of particles. They're all moving about through space in different directions. They're influenced by different forces acting on them, which sort of pull and shove them in different directions. You might even get some complicated motions from collisions or from maybe like gravitational effects, where they interact with each other. So there's some things about the system that we need to know in order to talk about the physics. So these are called the measurable quantities. And we'll just take a look at one of these particles. So do some of you know maybe some of the things that we can know about the system? Maybe? Okay. Sure.
Position, momentum.
Okay, yeah. Yeah, so let's talk about some of that. So there's the position that we can know. There's also the time. We can know the mass of this particle, the velocity, and the acceleration. And then we can define this thing called momentum, which is another important quantity in physics, which is just the product of the mass and the velocity. So what is energy? It turns out to be really, really simple, because energy is just a number. It's measured in joules. So that's all it is. What's important about the number is that it's a direct consequence of Newton's laws. So that means that we can derive some formulas to tell us what that number is. It's also a conserved quantity of the physical system, which means that it will not change in a closed system. It is also a sum of two other components. One is called the kinetic energy, which traditionally denoted as T, and U for the potential energy. The kinetic energy is the energy of motion of the particle. So the more speed it has in a frame of reference, the more kinetic energy it has. Potential energy is just a way to store that energy. And generally, the kinetic energy and the potential energy can sort of transfer. They can be transferred into one another. The form of the energy can change as long as, in the end, when you sum them up, they're always equal to what you started off with, which was E. So that cannot change in a closed system. So can we change the energy of a system? And it turns out that the answer is, yeah, we can. But how? Well, someone has to do something called work to change the system, the energy of a closed system. And what that means is that if you have a little particle that's moving through space, if you apply force to it over a certain distance, then you say that work has been done to the system and it has gained energy. So now it will be moving faster. So that's what the concept of work is. And that's the only way that you can change the energy of a closed system. So let's look at an example of this so-called perpetual motion machine. It was designed by this artist in Norway. So I have a video to take a look at to see how it moves. And it's just like 10 minutes of that. So anyways, that's what it looks like when it's working. So can someone tell me some things that they might have noticed about that video that may indicate that it's not a perpetual motion machine?
I can hear it.
Yes. It's losing energy through sound. It takes a certain amount of work to do that, so it is losing energy. Well, yeah. Correct. Yeah. So for you to have a real perpetual motion machine, you have to have that the energy of your system is not changing, so it can't be losing energy. The fact that we can hear it and the fact that it's just rolling around the track, losing its energy to friction, heating the track up a little bit means that it is losing energy. It is not a perpetual motion machine. So it has to have some sort of energy source, even if we don't necessarily know what that is. So let's talk about magnets. Yeah. So in a lot of these perpetual motion machines, they tend to say that the energy that is powering them is some sort of magnetic energy, as you saw from the first video. I'm not sure why that is. It's just very popular to talk about magnets. So what I want to say about magnets is that the magnetic field all magnetic fields are ultimately caused by or as a result of the motion of electric fields. So if you have like just an ordinary magnet, when you look inside of it, the magnetic field is ultimately comes from the fact that you have these little nuclei, and the electrons are orbiting around them, and that's a moving electric field, and that's where the magnetic, ultimately the magnetic field comes from, roughly. There's also some intrinsic magnetic field which comes from quantum mechanics, but that's beyond the scope of the presentation. but that's how it was understood. Yeah. So let's see. So the other thing that I want to say about the magnets, I have some here. Okay. So the way these things store energy is not from the magnet itself, but it's from the particle's position in the magnetic field. So when the magnet and just a little metal ball are far away, they have a lot of potential energy stored between them. The way that you get energy out of the magnets is when the magnetic field applies some force to the little ball and attracts it. So, so if you have a little particle moving along and it comes near a magnetic field, then the magnetic field will attract the little metal ball. It will gain some kinetic energy. Except to remove it, to make it go away from the magnet, it requires you to do some sort of work, which will release it from the magnetic field. So ultimately, you don't get any energy out of that. It's conserved. What it gave you is what you're going to have to take from it to take it away. There's this fact in physics that magnetic fields can do no work to electrically charged particles. So that means that a static magnetic field, such as a little bar magnet, like this one, if there's current flowing through it and I just hold it like this, it's not going to do anything to the motion of the, well, it's not going to speed it up. So you can't get energy that way either. The only way to get energy from a magnet is to have a time-varying magnetic field. But there's a bit of a catch to that. Does someone want to guess what the catch is? It takes work to have a time-varying magnetic field. So in this magnet, if I want to cause the electrons to move, to flow, to generate an electrical current, I'm going to have to move, the magnet in some way relative to the coils. That, of course, requires a certain amount of work to do that I have to do in order to get it moving. And there's other ways that you can have a time-varying magnetic field, but ultimately it will require someone to do the work to change it. So there's no free energy in that either, unfortunately. So I have here, there's this guy, his name is David Hamill. He thinks he built this little generator thing that is supposed to somehow unleash the free energy that's in magnets. And it's basically just a ring of magnets and with a little metal disc with a magnetic washer that's attached to it. And there's a video. Sorry, how much time do I have?
Lots of time.
Okay.
15 minutes.
Oh, 15?
You have 15 minutes left.
Oh, excellent. Okay.
Any questions?
Yeah, I'll see some. Okay. So let's take a look at this little machine that he has.
And anyway, his name's John. And then when John got up there and he said, "Now this is my gift to mankind." And everybody looks at him like, what's going on? He didn't say anything more about it. So he started the device. In other words, got the thing going. Every light bulb lit. Now, I'm sitting in the audience. I thought everybody would be all help, Not one word was said except for, "Get these damn light bulbs off my plate. I want my lunch." They didn't understand the application.
They didn't. You just
Now, see, what you do is you put a shaft on it. Don't put a metal shaft, a plastic one. Then you can put a generator on it.
Yeah.
And if you use the stronger magnets, you can really get a lot of power, and that's enough to create a field to create your generator. Then how is that free energy?
That is free energy.
No, it's not. Yeah, so the secret to that is that you actually have to be moving the little thing on top in order for it to keep on spinning. If you actually have it in a fixed position, then it's not going to keep spinning. So you always have to do some work in order to get these things going. You're not going to somehow extract free energy from magnets.
You mentioned John in the video. That's not John Searle, is it?
I don't.
Great John Searle.
I'm not sure here, actually. Yeah, so I also have this this little toy. Some of you have seen it already, if you watch The Simpsons, for instance. So you know what it's supposed to do. It's just tilt. It's a little more impressive when it's actually working, but these things are temperamental, and I'm more of a theoretical physicist. So, so you just have to imagine that it works. Does anyone actually have some idea of where the energy that drives this thing is coming from?
Yeah, so from what I understand, the beak of the bird dipping into the water allows for water to be brought onto the fabric head, which then evaporates, causing cooling to occur in the head, which then causes a suction effect, bringing liquid up through its neck and weighting it down, allowing it to drink more water.
Correct. Yeah. So. Okay. Yeah. So basically, as you mentioned, how it works, you don't need a cup of water to get it going, as long as the head is wet of this little bird. And what the wet head does is that as the water evaporates, it actually cools the head down a little bit. So there's a temperature difference. Temperature differences can actually have some potential to do work. So that so now that there's a temperature difference, that causes the gas in the head to condense, and now there's a pressure difference, so that will actually cause the fluid at the bottom of the bird to go to its head, making the head heavy, and then it begins to tilt. And when it gets to just the right at the right angle, then the gas from that's at the bottom will rush to the head, and then it will go back to where it began. And as long as there's water on the head that's evaporating, there's a temperature difference, so it'll keep going. It's not a perpetual motion machine, but many people don't understand how it works. So to the layman, it might look like a perpetual motion machine. But you always have to think about the energy source, and sometimes we can be surprised, like where it's coming from, like in this case. So to conclude, is perpetual motion a science or a pseudoscience?
Pseudoscience.
Yay. Pretty much. As far as we know, our understanding of physics, the way that universe work to, they say that basically it's impossible to have a perpetual motion machine of any kind. Be skeptical, not susceptible. So always be thinking critically. That's from, where was it? Reality Check, yes. I love that podcast. Questions?
What's the most insane perpetual motion machine you've ever heard of someone trying to invent?
There's this video, or it's a documentary. I think it was titled, let's see, pseudo. I'll have to remember the name later. But anyways, it's with the guy David Hamill, who actually believes that it's the aliens that have been talking to him that have given him information about how to create this technology. And he thinks he can build these like UFO saucer things that can move themselves somehow. So I think that takes the cake for the craziest one I've heard. Any other questions?
Perpetual motion machine implies that you're using perpetual motion to accomplish some sort of work, which acts on the system and wears it out. I don't know enough physics. Is perpetual motion in and of itself real? Can it exist without working on anything else, or do the forces, all the various forces?
Sure. Well, in real life, that's perpetual motion is not possible. But I mean, if you're talking theoretically speaking, if you've done some two-body motions, like when you work out how the planets, a two-body problem where one planet is attracting another one and they're sort of moving about, that in theoretical physics that energy is completely fixed. So I mean, from a theoretical point of view, yes, but in real life, no.
Yeah. On a practical purpose, it's more theoretical.
Yeah, I mean, conceptually, yes. Just like in space, if you push a particle, it's supposed to move forever. From a theoretical. Yeah. Questions? Zero point energy is, well, the way that I understand it is that at absolute zero, when there's no energy at all in a particle, it's not moving, and say you've gotten it down to absolute zero, which is also impossible, then this particle will still have some energy associated with it, and it's actually a quantum mechanical effect. It's like it's the ground state of a system, and no matter, like, if you remove all the sources of energy, that particle sort of is intrinsically has that specific amount of energy. Yeah. Yep.
Do you know of any instances where temperature differentials have been used to generate meaningful power?
Meaningful? I mean, well, in this case, there's the steam engine. If you use it to rotate something, you put some magnets on it, some coils, and then you're going to generate electricity.
I'm envisioning giant drinking birds.
Well, maybe if you were to put a small magnet on the head of this thing and a little coil, then every time it goes up and down, it's going to be moving the magnetic field. If you have just a ton of them, maybe you'll generate some voltage, some electricity. But I mean, with the little drinking bird, it's very impractical.
Isn't geothermic energy sort of?
Yeah, that arises from temperature differences too, because the center of the Earth is very, very hot. So it's a good source of energy, and the top is also cold relative to that. So
that is sort of similar.
Yeah, that's another thing. Yep. Yeah. Any other questions?
No, you have 5 minutes.
Okay. Let's see, what else do I have? Oh, and there's references. Yeah. So these are sort of great videos to watch. They're really fun. Yes, Donna?
So if perpetual motion is debunked, where do you think, especially here in Manitoba, where should we be concentrating our efforts on a different energy source that actually will work? An alternative to fossil fuels, things like that. Solar, wind, anything else?
Yeah, I mean, there's so many different sources of usable energy that you can use, like temperature differences. I don't see anything. I like wind power. So that's always a great way to generate electricity. Yeah. But I'm not an expert necessarily on generating electricity from the environment. I study the physics of those systems, more or less. But yeah, there's solar. Yeah.
You mentioned the free energy into something that's so cheap and so easy to produce. It may as well be.
Well,
not fully perpetual, but
it's a little different. There's a joke that's on the internet that where you say, like, the only way that you can get free energy is if you just take your power cord to your cell phone and go to someone else's house and plug it into their outlet. Then you have some free energy. But there's always a certain amount of work that's associated with it. So, but in this context, it's kind of like free energy. It comes from, I guess, what would be basically a perpetual motion machine that not only powers itself, but also is able to power other instruments, and that's not possible.
In physics, would the universe be considered a perpetual motion machine?
It's a closed system, so it doesn't lose its energy. I don't know if it loses its energy. I don't know. It loses usable energy because things tend to cool down, and things are sort of dead after a while. I think it's heat death of the universe. Yeah.
Okay, so if energy can be neither created nor destroyed, which is kind of what this is all around, where did all the energy come from to begin?
Well, I mean, you can always, you can. Well, you can always store energy like in different areas as long as the total amount of energy is what you started out with. So, let's see. So you can store energy like through batteries. Sorry, your question was like, where did it come from? I guess.
Yeah, kind of.
Initially.
It was, only sentence area.
Okay.
I don't know.
Okay, yeah. I'm not really sure. I mean, if you talk about particular closed systems and we know where the energy comes from, like Earth or whatever.
I've heard that there are some explanations for. I mean, first of all, we don't know is fine.
Okay, sure.
But I've heard some physicists talking about that you might consider gravity to be a form of sort of negative energy, and so the amount of total energy in the universe is effectively zero.
I've heard that.
And I've also heard the explanation that that you can. Okay, I'm being told.
Okay.
That's
I've heard that. I haven't studied it, so I'm not quite sure. But yeah. So, anyways, thanks for listening. Yep.
Basically, I work for a company that I won't mention the name of, but we have an emerging energy department, and they see stuff like you showed here.
Mm-hmm.
2 companies in Manitoba all the time.
Oh.
And they have engineers, like one engineer, just one story I'll share, where a guy comes in, he's got a great new furnace that's going to save Manitobans tons of money, and looking for an endorsement from this company that I work for. And basically, the engineer has to sit down with this guy and explain to the fellow, look, this friction furnace that you brought to us here is no more energy efficient than a regular coil thing. And so the conversation in this particular case kind of went on. And how much money have you got invested in this company? Turns out the guy had sold his house. He invested everything he owned in it. And I think this is a really important topic.
Yeah.
This happens right here. It's not just something you read on the internet and you hear about it.
Yeah.
Scammers are out there. It's really important.
But did you get a patent on it?
There's actually several perpetual motion patents, as I understand it.